Started with Kubernetes, hosted by RazorOps and in collaboration with DigitalOcean. So before moving on, I would like to introduce RazorOps to our new viewers. So RazorOps is a container native CI/CD automation platform where you can integrate your Git versioning tools like GitHub, GitLab, Bitbucket to create your workflow. And then also you can integrate your servers, Kubernetes clusters, container registries to deploy your bits on dev, QA, staging or production environment as per your needs. Also, I would like to tell you on every last Saturday of every month, we host webinars on industry relevant topics under the umbrella term Cloud or Container Native DevOps. Without wasting further time, I would like to move on and introduce our speaker. So our speaker for today's webinar is Ms Purnima Kumari. Purnima is a cloud solutions engineer at DigitalOcean, and today she'll be sharing her knowledge and experience on Kubernetes with us. So Purnima, hi.
Hi, Aditi. Hi, everyone.
Thank you for joining us today. So over to you. I'll be presenting your slides. Just give me a minute.
So while Aditi shared the presentation, anything I will give my small introduction. As you know, I'm Purnima Kumari.
Sorry, Purnima, for interruption. Your voice is little low. I'm not sure if everybody is able to hear you, but
Okay, fine. Is it better now?
yeah.
Yeah. Okay. So you guys know I'm Purnima Kumari. I'm solution engineer in DigitalOcean for APAC region. I am CK certified and I am in LinkedIn. If you want, you can get connected with me. My LinkedIn profile is Purnima-Kumari 18. So you can get connected with me there. And I am little bit I have spent more than 4 years in DigitalOcean right now. And in Kubernetes domain, container domain, I am working from last 2.5 years. So now, basically in this part of the webinar, I will talk about the Kubernetes and DigitalOcean managed Kubernetes. So let's move into the next slide. And so here in this webinar, I'm going to talk about revisiting the containers, what are container orchestration. I will talk about why and when to use Kubernetes. I will also show you guys a small architecture of Kubernetes cluster and sample of Kubernetes objects, workloads, and why you need it is essential to use, or why it is beneficial to use managed Kubernetes. I will talk about that. I will give an introduction about the DigitalOcean managed Kubernetes service, and also we will see some examples of the success stories on DigitalOcean. So let's move on to the next slide. And so maybe lots of you are already aware of this particular diagram, right? So when we started, we used with a traditional deployment model where we had hardware, operating system on top of that, and we used to run the application, right? This is how the traditional deployment model worked when we only had bare metal servers to run the workloads. There was little to no isolation, right? And the application had to be like very careful while using the resources. Also, we started putting more and more computing power to the hardware. However, this particular model was not efficient, right? Efficient enough to take care of all the computing powers and divide those resources to the servers. So we needed a better way where we can use the resources in more efficient way. So hence the virtualization was born. So the idea behind the virtualization was, as you can see in the screen, in the virtualized deployment diagram, here is an hardware, on top of that operating system is there, and above that hypervisor is there, right? And above that you are having a virtual machine. So what is an hypervisor? It is essentially a driver like your KVM, which helps you to provide the isolation for your multi-application environment. Okay. And when I say application, I meant to the virtual machine. In the diagram, you can see there are two different virtual machines are running. On top of that, operating systems are there. For these virtual machines, they have separate operating systems, libraries, binaries, dependencies will be there, and applications are running on top of that. Okay, so this will help you basically to use the resources of your server, because hypervisor will take care of that, and it will isolate the environment for your application here. So it will, by using the virtualization, what you are doing, you are taking the advantage of increased resources by putting the hypervisor. You are isolating the resources also for your applications. You are dividing the server resources, right? So, but there is something wrong here. Not wrong, I will say there's something like we are using operating system on top of hardware also. In virtual machine also we are using the operating system, right? So what's next after virtualization? So the next leap was to remove the redundant operating system layer. So just think, what if we can use the already existing operating system itself, right? So in that case, what will happen? Container runtime came into the picture, and it helps you to isolate at the operating system level rather than doing at the kernel level. So if you look at the rightmost diagram, you can see there application is there, and before that container runtime is there. So there is, after hardware, there is one operating system, and container runtime will make use of that. And on top of that, different containers are running. So that redundant operating system has been removed, right? It has saved the resources, timing, it has made it more quicker and faster. So this was the world when containerization comes into the picture. And here it's an application feels like they are running into the bare metal, because it has all the libraries, binaries, which is needed to run that particular application on the container itself. So this is the journey so far, how we started with the traditional deployment and how we came to the containerization world. So it was just not the way of doing the infrastructure has been changed, right? With containerization coming into the picture, the way of designing the application has been changed. So if we will go into the next slide, and we can see there is an architectural diagram. You can see here on the left side, there is a traditional way of deploying the application that is called monolith, right? It contains all the components in it together. Let's say you are having an application, like you have front end, back end, and database. When you're doing an application in monolithic way, you will combine all of them together and run inside a virtual machine. Okay. However, when you talk about containerization and running containers, you will break those monolith into a smaller components. Okay. It's not just like you are going to break your front end. You can break your back end into smaller pieces, right? So let's say I'm taking an example. You are having an e-commerce site. So there you will have different services, right? Login will be there, carts will be there, checkout system will be there, catalogs will be there, payment will be there, you will store the card, service will be there. So what you can do, you can divide these different services into smaller services. Instead of having them together, you can divide it into the smaller part. And in that way, what you are doing, you are dividing the big monolith into the smaller part. And these smaller part itself is known as microservices, right? So other than just changing the way the application was deployed, your e-commerce application was deployed, with the advent of container, what you have done, you have changed the way you have designed your application itself, right? So now coming next part is about containers. So let's go and let's talk about the containers. So in the next slide, we will talk about containers and the container orchestration. So the very basic thing, what is container? It is a package of application code with all its dependencies. So container will include everything that is needed to run your application, right? And it is built on two Linux kernel features. So first is namespaces, second is C group, fine? So namespaces comes into the role. These two are like Linux based concept, right? So namespaces, what it does, it do the process isolation for you. And C group, what is this? It do the resource limit for you. And why they are important? Actually, why containers are important? Because they are resource efficient. As we have seen, we can make use of resources efficiently, right? It is fast. So why it is fast? Because it is lightweighted, because it's not running the entire operating system, right? In the previous slides we have seen, it was not using the entire operating system. We are having an underlying operating system, and we are making use of that, just having a different binaries, libraries on it, and we are making use of that, right? Now, there are different container images runtimes comes in. So there are different type of container runtimes like Docker container, and there are container registries also. So container registries comes into the picture because there should be some place where you need to store the container images, right? So in container registry, you can store your images, and you can push your images in the registry, and you can pull it to any another system like Kubernetes cluster. So DigitalOcean have Kubernetes service. I will talk about them in after a couple of slides. So we have Kubernetes service, managed Kubernetes service. Also, we have container registry also, DigitalOcean container registry, DOCR. So you can integrate both of them. So this is basically why container registry is also important. So now moving on, now containers are well, right? It's good. But if we remember what we have discussed in the last slide, we are dividing the monolith into microservices. Let's say you have high availability setup. You end up having hundreds of microservices, right? And each microservices could run inside one container, right? And in that case, what will happen? You will end up having hundreds of containers there. So now the problem here is like how you are going to manage those 100 containers. How you will know something has went wrong there, how you will know how you are going to restart all of them. So maintaining or taking care of 10 containers, 20 containers is not a problem. You can do it. However, but when you need to deal with hundreds, thousands of containers, then it becomes a problem. And that's the problem what container orchestration system is trying to basically resolve here. So what they do, they handle the deployment of your application, they do the management part, they do health check for your application containers. They will make sure your application containers are running fine with the health checks and all. Security will be taken care, and the networking will be taken care. And one of the most famous orchestration systems is Kubernetes. So before moving into the Kubernetes details, just wanted to quickly check here if any one of you know why Kubernetes is also known as K8s. So if you guys know, you guys can unmute yourself and tell, or you can write in the chat also why Kubernetes is also known as K8s.
There are exactly 8 letters between K and the last letter T.
Right, Gagan. So that is the reason. So it's when I have started long back by studying the Kubernetes, so the very first thing when I was studying through some of the materials, the very first sentence I read about was like why it is known as K8s. So yeah, lots of people don't know why it is known as K8s. Just to tell you guys again, as Gagan has told, there are 8 letters in between K and S. That's why it's known as K8s. So let's move into the next slide, and let's talk about Kubernetes. So Aditi, can you move to the next slide? So the way Kubernetes has grown is phenomenal. Okay, why I'm telling this is like it is one of the most famous open source project on GitHub. Okay, and it is highly developed as well. There are like thousands of developers fixing bug, creating new features, and there are features that keep moving from alpha to beta, beta to stable versions. And there are around one release per quarter. Basically, we can say like it's evolving pretty rapidly, right? And it is governed by CNCF, that is Cloud Native Computing Foundation. And what basically they do is they oversee the Kubernetes governance, whether everything is done without like unbiased way, and if the code of conduct is being followed or not. So now let's talk about why Kubernetes, right? This is important. So most of the points written under why Kubernetes is similar to why could you use a containers, right? So now the only difference here is Kubernetes also creates a layer on top of the containers. While you use the containers on top of that Kubernetes create a layer. So let's get into that, like why we need it. So the very first thing is like Kubernetes is having a smartest scheduler which will distribute your load on the worker nodes automatically, with the help of which the resource is being used efficiently. Also, it improves the workflow of application and CI/CD process pipeline. So, with the help of that, what is happening? Productivity has been increased. And in Kubernetes, there is just one command. You can, with the help of one command, you can scale up or scale down your application. So scalability is also there. Apart from that, while you run your production server, the one important feature is like high availability, right? So it will maintain the high availability of your application using the built-in services itself. Also, for example, if you are running a container and that particular container fails, then what will happen? So it will auto restart the failed application in order to maintain the state, because it needs to maintain the state of your container pods. So because of which, how it is in, because it is having a feature, self-healing feature is there in Kubernetes with the help of that. And in what all cases you can make use of Kubernetes, right? So when the workload is stateless, you can make use of that. When you need to scale your application need to scale up or scale down. Because scaling doesn't mean always like it need to have the feature of scaling up. Scaling down is also important, right? So when you need to scale, you can make use of Kubernetes. Also, when you need containerization, you can make use of that. And when your workloads are portable, and when you are using microservices architecture, you can make use of that. Right, and let's let's move to the next slide and let's see a simple component architecture diagram of Kubernetes. So, Aditi, can you please move to the next slide, please? Okay, so this is a basic diagram, right? It is no way like it is having an exhausted list of components there. Since this is 101 session, I don't want to dive into go deep into the architecture part, and just wanted to give you guys an overview. So we will start with nodes. So Kubernetes has a typical master node architecture. Why I'm saying it is having a master node architecture is like where you can see there is a master, which is also known as control plane, and that takes care of all the management actions. So when you have a worker node or worker control plane, you need to execute some instruction, right? You need to give some instruction. Those everything are taken care, execution part and all, really management part will be taken care with the help of control plane itself. So if you look at the diagram, we have got nodes there. 3 nodes are there. So these nodes are basically these are the worker nodes, we can say. And these nodes are having 2 primarily components. The very first one is kubelet and second one is kubeproxy. Okay, so or we can also sometimes people say kproxy. So then don't get confused. Kproxy itself is kubeproxy. So kubelet is like agent that work like a bridge between your worker node and your control plane node. It takes all the information about your nodes, like your resource usage, CPU, RAM, disk. If there is disk pressure, it will take those information and it will provide that particular information to the control plane. Why? Because control plane can make effective decision whether the new worker load can go to which particular node is having the resources so that it can run that particular workload. So now now the control plane basically makes a decision for where your workload should go, right? Whereas the another part, that is kubeproxy, takes care of the networking related stuff. So when you deal with complex system, the networking get more complex, right? Networking is something gets more complex while we get into it, gets messed up, right? So to have that is what you proxy do. It sets up the IP tables. Why it sets up IP tables rules is because so that your network packets can reach to the destination. If you have requested for some specific resources or something, so what you will do, it will set a rule for you, and your packet will reach to the destination correctly. So you can see in the control plane there are API server in the center, right? So why API is in the center? Because it is basically the center of the control plane, because it will get you connected with all the other components in the cluster. So that's why API is important. When your API server gets down in Kubernetes cluster, you will face an issue with connectivity, access. So that's why API server is important there. Also, another important component is etcd, because it stores all the data of the cluster, state of the cluster. It is basically a distributed, we can say a distributed key value store where all the data are stored, including metadata, configuration data, and allow your Kubernetes cluster to read and write the data also. Okay. Also, we have a scheduler there. So a scheduler will help you to make a decision like where the workload should go. Like they have some data points like how much resources your workload need, which node is up, which node is not having any levels or so by seeing those data points, it makes decision. Okay, this particular workload should go to node A, node B, or node C, whatever node is fulfilling that particular set of points. So now also we have a CCM there, right? So that is Cloud Control Manager. So before coming to the Cloud Control Manager, I just want to quickly tell about the Controller Manager. So Controller Manager is there to make sure that the state of the cluster is maintained. So there are different type of controller managers. Say replication controller is there. Lots of other controllers are there, right? And cloud controller manager comes into the picture, CCM, when you want to use a cloud provider. So DigitalOcean also have their own CCM. So basically when you see into this particular diagram, all the components in this particular diagram is required to run your cluster properly. If you are interacting with cloud provider, then CCM is also really important there. So now let's move on and let's talk about Kubernetes objects and workload. So in the next slide, we will see the very core concept is Kubernetes namespaces. Aditi, change the slide, please. So one of the core concepts in the Kubernetes is namespaces. Why I am saying it's a core concept? Because see, the very first thing I want to discuss here, don't get confused with the Kubernetes namespaces and with the kernel namespaces. So similarly, both of them are having quite similar functionality. However, the kernel namespaces provide isolation to the process, as we have discussed earlier. But in Kubernetes namespaces, it provides isolation to the Kubernetes resources. So what it do is like it allows you to divide your cluster into different scopes. Let's say you are having a different teams, like you have billing team, developer team, you are having a support team, and you want to have all the team have different resource quota. So what you can do, you can create a namespace and you can assign each team to its own namespaces, and it will use that allocated quota itself. So the primary reason of mechanism, I can say, of namespaces is for scoping and limiting the access also. So your billing team member won't be able to see what is going on inside the namespaces of developer. Developer won't be able to see what is going inside the namespaces of your support team. Vice versa, it will go. So it provides the access limitation also. And by default, whenever you create a Kubernetes cluster, you will get three namespaces. The very first one is kube system, kube public, and default. You will get it. Next is pod. Pod is the smallest unit of deployment in Kubernetes, and it can contain more than one containers also. So inside one pod, you can create 1, 2, 3 multiple containers also inside that. And you can have network storage resources are also shared among the containers on the pod itself. If you are having a storage resources for any particular pod, so containers inside that can share that. Next is deployment. So deployment is an object that basically contain your application and it helps you to run the replication of that. It will basically replace the failed pod. For example, if you are running a pod, if that pod goes down or it's in terminating state for some reason, so in that case, what will happen? Deployment will make sure the failed pods are replaced with the healthy ones. Okay, and it will help you to scale up and scale down your pods also, and do that, and you can increase the number of replications also. We will see an example in the next slide of one of the deployment. Okay, apart from that, we have services. So services is basically used for exposing your application, right? It is used for load balancing the traffic, and the routing basically happens in services with the help of labels, and there are different types of services like cluster IP, node port, load balancer is there. Okay. While talking about the storage in the Kubernetes, PV and PVC comes into the picture. Okay, so PV is basically a storage volume that you can attach to the pod. So why PV is important, and why there is one really interesting thing, like in Kubernetes cluster, worker nodes are ephemeral in nature, so it gets recycled. So that's why we don't recommend customer to store their data in the worker node itself. So in that case, what you need to do, you need to create a block storage volume somewhere else, and you can get it attached. So even if the worker node pods get recycled, your data will be safe in the block storage, right? And there are different way of creating the PV. First is like you can use the static provisioning, and second is like you can create on the fly. Why I'm saying create on the fly? Because it will be created dynamic in a dynamic way with the help of block storage class. So DigitalOcean itself has its own storage class also. So when you create a PD, what will happen? It will create a block storage on DigitalOcean platform. So you can make use of it and you can store your data there. Now next is PVC. So it is, in simple term, I would say PVC consume PV resources. Why? It's like that because when it is a request storage by user, when you request for a storage like I want 1 GB, so you create a PVC, it is going to claim that much. It will claim that persistence volume, 1 GB volume for you. Okay, and PV and PVC comes hand by hand. So if you create PVC, you will create PVC also. Okay, in the next slide, I will show you an example of some of the YAML file. Aditi, move to the next slide. So the next important thing is like, now how do you define pod, right? This is also important. How you are going to tell the Kubernetes like, okay, I want to run a pod. This is important. This is the concept what we have run theoretical. But Kubernetes does not know what is container. They know pods because pod is the smallest unit, right? So they know what is pod. So now, when you need to talk to the Kubernetes cluster, you can make use of kubectl, for example, okay? And you can put your data information in the YAML file or in the JSON file. Here I have taken an example of YAML file, okay? So the very first sample is for pods. So while writing a YAML file, at first you tell about the API version. Why we are giving the details of the API version here? Because we need to know which API group we need to talk and we need to post the request, right? So that's why we are using an API version. So it's a V1. Pod comes under the API group of V1. And after that we will use the kind. Of course it will be pod because we are creating a pod here. It will have a pod, and after in metadata it will have a generic information like labels, names. So here we have given the name Nginx pod. And under the specification, you can see there is a containers. In that container section, we have given one name. Name is there, image is there. It means we are creating one container there. Okay, if you want to have another container, you can make container, another line you can write like name, Redis, you can use image, whatever Redis image you want to use. So here what is happening, the name of the container is Nginx and the image used for that particular container will be Nginx latest. Why latest? Because it will fetch the latest version. That's why latest tag is being used here. And for deploying it, you will make use of kubectl, apply -app, and you can put this entire file in the YAML format and you can make use of it. Now next example is about deployment. So here you can see in API version it's different, apps-v1, right? So because the API group has been changed, so that's why it's apps-v1. You can check about these like different API version, what resources, objects comes under which particular version with the help of like Kubernetes is having their own community. You can go and check on their official document also. You will see lots of sample files there. Okay. So next is time deployment. It will be deployment of course. Next, metadata will have the name, Nginx deployment label is there, like app label is there. Why app label, that particular label is being used? Because that deployment need to know which pods I need to manage, right? That's why that label is being used, app Nginx. So what, after that in the specification section, before container, you are seeing replication. So 3, why it's given 3? Is it because it is going to create 3 different pods for you. And in down, if you will come to the down, it's like specification is container. So it will again create a container with the name Nginx, with the Nginx version 1.14.2, and it will have a container port 80. Okay, fine. So while you will run this particular, while you will execute this, you will post this request, it will create a deployment which will have 3 replicas. 3 replicas means it will have 3 pods, and each pod will have 1 container running on it. Okay. So next is the example of service here. So this same yeah. So in this service, you can see like this is having same API version. It comes under V1, and this specification basically is going to create a service object called my service, and which will target the TCP port of 9376, and any port with the app label, with the label selected what we are using there, app, my app will make use of that. Yeah. So now let's talk about now we have discussed about Kubernetes. Now talk about why manage Kubernetes, why it is important. So in the next slide we will see, like let's take an example here. Like you are having a car. Let's say you have purchased a car from any company, XYZ company, and when you buy a car, you are the owner of that car, right? You are responsible for the entire cost of the car, whether that the cost of that car is 10 lakh, 12 lakh, you are going to pay that entire 12 lakh. You will do the maintenance of that car. If something goes wrong, you will do the maintenance, you will have this insurance paper, everything you need to take care of that. However, the one benefit there is that if you want the color of the car should be red, white, black, whatever, you can make use of that. If you want petrol, diesel car, you can make decision there, right? If you want sunroof or not, you can make decisions there for these features. And you can make modification also there. Now, just imagine you don't have car, or if you have moved, right now you are in Bangalore and you went to Mumbai, and you want to travel from Mumbai to Pune. So what you do, you take or rent a car from the rental companies, right? So when you take a car from the rental company, say for 3 days you are taking a car for rental company, you don't own a car, right? So, and also you don't need to worry about whether the actual cost of that car is 10 lakh or 20 lakh. What you are going to do, you will pay for only 3 days. Like if you are booked for 3 days, you are going to pay for 3 days. If you are booked for 5 days, you are going to pay for 5 days only. You are not going to pay for more than that, right? You are not responsible for maintaining that car, insurance paper of that car, right? And also, if you want XYZ car, if it's available, you will take that car. If it's not available, you can't make changes. Like I wanted a red car, you can't go and tell, okay, paint this car to red if it's black in color, right? So while taking that from car rental company, you only pay for a specific number of days. You don't have headache of doing the entire payment, or for maintenance, whether mileage is good or not. You don't need to take care of those things, right? You just use it, and after that you return back to it. But however, if you think about the rental companies, they need to take care of that car. If you will give that car back to them, they will again do the maintenance of that car. They will do servicing and all. They take care of all the actual money, how much it costed to buy that particular car. They will pay, they will maintain, they will take care, like, okay, I have 10 cars, I have given 8 cars, 2 cars are left. So they will take care of all the mathematics, all the other stuffs there, right? And they can control the car model and other stuffs. And you won't be able to make any changes. Same goes for managed Kubernetes also. As discussed till now, managed Kubernetes is like Kubernetes itself is complicated, right? Right? As we have seen. So by using the managed Kubernetes, what happens? It's same like you are owning a car. If you want to use it for 12 months, 13 months, you will use it. 12, 13 months, you don't need to worry about the infrastructure running on back of it. You just need to run your code, you can deploy your applications there, and the managed service provider will take care of the infrastructure. You will just pay for the third, like 10 months, 12 months, 2 years, whatever duration you want to use, you are going to pay for that much time. And after that, all the headache goes to the managed provider here. So now the thing here is like, we have gone through the slides about the Kubernetes, managed Kubernetes and all, right? If now I say you guys like managing Kubernetes itself has become a lot simpler. So most of you will think like how it is possible. Kubernetes is complex. It is time-consuming task. We need knowledge about Kubernetes, right? So however this is possible, you can make use of that with the help of DigitalOcean Kubernetes Service. So in the next slide, I will be talking about the DO Managed Kubernetes Service and the key highlights there. Okay. So let's move into the next slide. And so DigitalOcean is having a concept of making simple solution for the complex issues, problems, right? So using DigitalOcean Kubernetes is really simple because it has been made simple for our users. Why? Because managed Kubernetes is built basically to enable deployment team, whether you are having a large team or a small team, you can take advantage of this particular market leading orchestration platform without like worrying about the lead time for provisioning, installation, operation of your cluster. You don't need to worry about that. So by managing, and there are some benefits, like it will reduce your operational overhead. Why I'm saying this is like, while managing self-hosted cluster requires expertise, right? It needs time, it needs resources. That means small businesses lack. That's true. And by using the DigitalOcean Kubernetes, DigitalOcean does the heavy lifting part. And how we do the heavy lifting part? We do the continuous monitoring of your Kubernetes control plane to make sure you are able to access and deploy your cluster. We manage the key services and settings and on your behalf, so you don't need to worry about your Kubernetes cluster going down. We will take care of your cluster infrastructure. You just need to make sure your application codes and everything, whatever deployment workload is done, you need to just take care of it. You don't need to take care of control plane or worker nodes, what is happening there. We are going to take care about that. So by using the managed version of Kubernetes, it allowed developers, business to take advantage of this by leading to the faster time to market, because your time is being saved for maintaining the entire infrastructure. So you can focus on your code, you can focus on your application deployment, right? And one of the common concern we have seen in the managed service version is like of Kubernetes is like people do lock-in by using like to the certain.
No, we have one question coming from Arun. So Arun, you can speak. So it should run.
Yeah, thanks. Am I audible? Hello?
Yeah, Arun.
Okay, yeah. So we are in an enterprise company where we have this AWS as a kind of infrastructure as service. So what we could do in order to migrate from AWS to the Kubernetes, or we can still rely on AWS with the Kubernetes. So we have few queries over there. Could you please resolve that one?
Yeah.
Arun, if this is the like solution question, we can take off after the session.
Yeah.
But if it is related to the session, we can ask right now, so other people also can get understanding of what CG is speaking. But anything related to this kind of things, we can talk after the session.
Sure,
Like
sure.
during the QA session, basically, that time we can talk.
Definitely. Thanks, Sean.
Sure, thank you.
So, okay, I will then continue here. So, yeah, so I was like talking about there is no lock-in basically. So there is one common concern when people get into the managed version of Kubernetes, that is that they log in by with a specific configuration, specific setups like managed provide, and can't make changes there, right? So in DigitalOcean, we don't lock in, and you can build your Kubernetes cluster on DigitalOcean. However, you could and you will have the flexibility to make changes if you want to make changes to some of the configuration. You can do that. And also, we are close to upstream Kubernetes. Why I'm saying this? We are close to upstream Kubernetes because we support features that are in beta and general availability stage in the upstream Kubernetes version. We try to get closer to the features which is provided in the upstream Kubernetes itself, like in the vanilla Kubernetes, basically. We have digital availability there. Like we have data center in all the regions, whether it's APAC, EMEA, or Americas, we have data center there where we support Kubernetes. Apart from that, we have like auto scaling feature is there because this is really important in Kubernetes, right? So you can have a cluster auto scaler, and you can adjust the size of the Kubernetes cluster by adding or by removing the number of nodes. You just set the number of nodes. I need between 5 to 10, and the auto scaling will be done automatically by seeing the resource uses in your nodes. And let's say you are having some events going on, you are having some sale on your e-commerce website on 10th of June. So what will happen till 9th of June, it will run on 3 nodes, and on 10th of June, if once the traffic increases, resource users increase, and what it will do, the node size will, like number of nodes will increase automatically. So it will give smoother customer experience, user experience there. After that, logging monitoring is also there. So we include metric visualization to provide insight about your health of your Kubernetes cluster and deployment. You can make use of that. And also we have marketplace image, which you can easily integrate with the Kubernetes cluster. Also, you don't need to worry about your upgrades and packages because we schedule the automatic update for your cluster to the newer version so that you can utilize the latest enhancement of the orchestration platform. Apart from that, you can get integrated, integration is there. You can integrate with another DigitalOcean products like load balancer, block storage, container registry. Our API is very robust and easy to use. So you can make use of API for automating the task and all. And there are different type of droplets. For say, if you're using a Kubernetes cluster for your testing stage, right? In that case, you can make use of maybe basic droplets. But if your application is memory extensive or CPU extensive, you can make use of optimized droplets. So CPU optimized, memory optimized, storage optimized. So you can make use of that. Apart from that, you can make also use of general purpose also there. So these are some of the common highlights of the DOKs. Apart from that, in the next slide, I will quickly cover about some of the success stories on DigitalOcean. So as you can see, Hack the Box it's on our platform. They are hosted on our platform. And the CTO James, what he has told after using our Kubernetes is like the fact that it's so easy to configure, administrate, and scale with DigitalOcean is something which I love. So they have used Kubernetes, and they had self-hosted Kubernetes, and while they have used DigitalOcean Kubernetes, they have seen the experience was so seamless and it was so easy to use. And apart from that, there is another company called Batch who has used Kubernetes cluster. They have like big workload and they have moved it, and it has worked like really good with them. And they tell like Managed Kubernetes is amazing. It has exceeded our expectation. We haven't heard any issues with it, and we have run really big workload in it, and the product is really good. So apart from that, as I have told, DigitalOcean makes simple solution for your complex issues. So yeah, the head of product Patrick tells like it's easy to use, understand, and so that they have time, they can give more time to configure everything. Instead, they can give more time for writing the codes itself. This is what DigitalOcean is. And yeah, now let's move into the next slide and we can move into the Q&A session.